All right, let's rock this one. Maybe the most important video you will watch on rational functions. Identify all asymptotes and intercepts of the following rationals. All right, busy. Gotta go. Okay, let's start with the vertical asymptotes. The vertical asymptotes can best be found by factoring the denominator. So what we have here is a difference of two squares. We can factor that to this. Now, well, let's just do it as we go. I mean, that's telling us the vertical asymptotes, right? So therefore, we've got vertical asymptotes. Let's put it down here. Vertical asymptotes of x equals 2 and x equals -2. Think about why that is, everybody. That's because a vertical asymptote is a discontinuity. It's a break in your domain. Why do we have a break in our domain at 2? Because when we plug in 2, we get 0 in the denominator, and you would be dividing by 0. Dividing by 0 is undefined in math, hence the vertical asymptote. Now, the x-intercepts would be found by factoring this. But guess what? Badly designed problem, because the x-intercepts here are going to be irrational numbers. So I'm not going to find them. Why are they irrational? Because if we find this is a quadratic, and if we find the discriminant of this quadratic, we get 1 minus 4 times -3 times 12. We get 1 plus 144, which is 145. Because 145 is not a perfect square, right? It's bigger than 12 squared and less than 13 squared. Then when we find the zeros of this, they will be irrational. So there are, in fact, x-intercepts for this function, but I don't want to find them because they're going to be irrational. So let's move on with our lives. We're not going to find all the intercepts. Sometimes you just have to deal with that. What are the x-intercepts, however? Oh, Lord, I just said I wasn't going to find those. What is the y-intercept? Sorry. The y-intercept can be found with the standard form. Y-intercept is when x equals 0. So if we do g of 0 in the standard form, we get 0 plus 0 plus 12 over 0 minus 4. 12 over -4 is -3. So we get a y-intercept of 0, -3. Okay, and then last but not least, let's do the asymptote, horizontal style. Horizontal asymptote, let's do it the short way because I rambled on a bit. So let's save some time here by saying the horizontal asymptote can be found by looking at the leading terms. If the leading terms have the same degree, we can just find the ratio of the leading coefficients. -3 over 1 is -3. So the horizontal asymptote will be y equals -3. If the degrees are equal, you're going to have a horizontal asymptote at y equals whatever the ratio of the leading coefficients is. Next one. Okay, let's go straight into the factored form. The factored form here, please tell me we can factor this. Oh, Lord, it's the same situation as before. Maybe I should find it anyways. But we've got the same situation as the previous one because this is a quadratic. What am I talking about? I'm talking about finding the x-intercepts. This is a quadratic. To factor this quadratic, you would only have rational numbers if the discriminant is a perfect square. It is not. In fact, it's a negative number. So this time you won't have any x-intercepts. Let me go back here. This will have x-intercepts, but they're going to be at irrational x values. So I could find them, but I won't. Here, we won't even have any x-intercepts. This has no x-intercepts because the fact that the discriminant is negative means no real zeros for the numerator, which means no x-intercepts. But there is a vertical asymptote. The vertical asymptote will be x equals -2. The y-intercept we could find from the standard form by plugging in 0. If you plug in 0, you get 0, 0, 3 over 0 plus 2 is 3/2. So the y-intercept is 0, 3/2. X-intercept does not exist. This graph will not intersect the x-axis. So again, I'm feeling a little sleepy today. The x-intercepts here will exist, but they'll be irrational. Here, they just simply won't exist because this graph is not going to intersect the x-axis. And then last but not least, I'm not going to write horizontal asymptote. This doesn't have a horizontal asymptote. How do I know? Here, the degrees were equal. Degrees are equal, you're going to have a horizontal asymptote. Here, the numerator degree is greater than the denominator degree. So in order to find the asymptote, should use division. Should I use synthetic, pathetic division, or just polynomial regular? I'm going to go with the old classic polynomial division. Okay, so x squared divided by x is x. And you notice you can still find some information about that end behavior asymptote by just looking at leading term divided by leading term is going to be x. But we need more information. So if we continue here with our division, we get -4x plus 3. Continue -4x divided by x. We're going to get -4, -4x plus 8, -5. So this is not a horizontal asymptote, it's a slant asymptote. And the equation is our quotient. Our quotient is x minus 4, so our slant asymptote is x minus 4. So by the way, I didn't write the fraction form here or here. What would the fraction form of this equation be? F of x is literally equal to this, x minus 4 minus 5 over x plus 2. This is equivalent to this, which tells us that our slant asymptote is x minus 4. As we approach the right-hand side of our graph, as x approaches infinity, this equation becomes just x minus 4, because as we plug bigger and bigger x values, this tail, we call this tail, goes to 0, right? If you plug in 1 billion, it's going to be -5 over 1,000,000,2 is basically 0. So it's going to look like x minus 4. So there we have it. Asymptotes and intercepts of a rational function. The factored form, this is already factored, tells us our vertical asymptote. The standard form is helpful for finding the y-intercept. And the fraction form from division helps us find our slant or horizontal asymptote. Should I do the division here to find the horizontal asymptote? Sure, why not? Nobody's got anything better to do, right? So if we just want to do one more step here to find the fraction form, we'll see that our horizontal asymptote is -3. -3x squared divided by x squared is -3. Multiply -3x squared plus 12. X 0. So there we go. G of x, our original function here, is equal to -3 plus x over x squared x squared minus 4. And so the end behavior, as x goes to infinity, this tail is going to go to 0, and we're just left with -3 on the end. And why does this go to 0, by the way? Is because this is, of course, as x goes to infinity, this gets bigger and bigger. But x squared gets bigger and bigger more quickly. So you're going to have a big number over a giant number. That's why this goes to 0. The tails are always going to go to 0 in these fraction forms because the tails will always have numerator degree less than denominator degree. All right, feel free to ask me any questions you have, but I'll leave it there. Keep asking questions, and as always, go blue.